Hello everyone. So today we're going to be finding the inverse of a function as well as the domain and range of a function and its inverse. So that's what we're tasked here with this problem here, to find the inverse of the following function as well as the domain and the range of the function and its inverse. So our function as is f of x equals quantity 3x plus 1 divided by quantity x minus 5. So we're going to start by just finding the inverse first, and assuming this is invertible. And the main idea here is when you take a function and compose it with its inverse, which we often call f to the minus 1 of x, with that notation, this equals x. And that's the main idea here. Now, there are like some standard steps to finding inverses here, algebraically speaking. The first step here is that we're going to replace f of x with y in the function that we're given up here. So this is going to look like y equals 3x plus 1 over x minus 5. And that is actually not even necessary at all here. You could actually go to step 2, but a lot of traditionally it's done in that way by many people, and many teachers teach it that way, so I just wanted to start with that. But you could totally start with step 2 here, and step 2 though is necessary. We're going to switch x and y here. I'm going to have x equals 3y plus 1 over y minus 5. And that step is due to that right there. And what your task is this. Once you switch the x and the y, you're going to solve for y. Okay? So this is always going to work out in this manner. Step 1, replace the f of x with y. Step 2, switch x and y. And step 3, solve for y. So how do I solve for y given this equation? I'm going to start by getting rid of the y term on the denominator, that y minus 5. So I'm going to multiply both sides by y minus 5. So you get x times y minus 5 equals 3y plus 1. And I'm going to distribute the x inside that parentheses. And the reason I did that was I want to be able to collect all the y terms together. And I'm going to go ahead and subtract 3y on one side and add 5x on the other. And I'm going to factor y out. And you would get x minus 3 equals 5x plus 1. So again, we got all the y's on one side and everything else on the other side that didn't have a y on it. And our goal is to isolate y equaling something. And that's what we're about to do. We're going to go ahead and rewrite this as 5x plus 1 over x minus 3. And there we go. We have solved for y. One step a lot of people are a little confused about, let me just get to that right now, is where I go from xy minus 3y to y times quantity x minus 3. So a lot of people ask me, why is it we're able to do that, or why would we want to do that? First thing is that if you look at xy minus 3y, those are two non-like terms. I know they both have a y, but I can't combine those two terms to make one single thing. So what I can do though is I can simplify this by factoring a y out, and you get y times x minus 3, and from there I can isolate y. And technically here for our last step, it's not really a step, but typically once you reach y, you replace the y with f inverse of x as such, and that's it. So you found your inverse. Now, for the part where we have the finding the domain and the range of your function, we want to use these two facts right here of your function and your inverse. The domain of the original function is equal to the range of the inverse, and the domain of the inverse equals the range of the function. So if you can find one or the other for a function or for its inverse, you can find the other quantity here that we're looking for. So if we looked at our original function f of x, my domain here would basically be anything that does not make that denominator equal 0. So basically x does not equal 5. So my domain for f, writing this in interval notation, would equal negative infinity up to 5 union 5 to infinity. And that, by what I have boxed in there by those facts, this would equal the range of the inverse. And likewise, if I took my inverse function, which was 5x plus 1 over x minus 3, and if I found the domain of that, it's basically when x cannot equal 3, the domain of the inverse would equal negative infinity to 3 union 3 to infinity, and that would equal the range of my original function. Okay, now a lot of people ask me when I started off here, they'll say, hey, you got the domain of your function, why don't you just get the range? Getting the range from the original function can be done, but sometimes it's a little harder to do. Sometimes you have to actually graph this, or it's easy to graph this, or it's easier to find it by graphing. However, graphing can be difficult, like it would be here. Not impossible, but it's so, in my opinion, not worth your time, though it can be done. And what I often find easiest, though, is to using these facts. So when you're finding the domain and the range of the domain of a function, its range, and vice versa for the inverses, for me, the simplest thing to do is take your original function, find its domain, that's the range of the inverse, and take your inverse function and find the domain of that, and that's the range of f. Okay, so using those facts. All right, and I will make another video on finding the inverse of a function that is not necessarily invertible. So, and I'll make a link to this video. Thank you.